Welcome. My topic is linear function and function notation, Unit 5, building models. Hello, friends. Just a quick joke to start off with. What shape is usually waiting for you at Starbucks? A line. I thought you might like that one. I'm Desiree, and I'll be talking mostly about linear equations for the next few minutes. I'll be going over linear functions with a simple algebraic expression, and I'll plot the points of the corresponding pairs. I will also define what function notation is. 2 points are plenty to illustrate a line. We can find 2 points lying on this line, plot them, and intersect them. So y equals 2x plus 6. So if x equals 0, then we know that y equals 6. So that's 0 and 6. If y equals 0, then we know that x is negative 3. So the next point is negative 3 and 0. You can see the 0, 6 and the negative 3 and 0, the 2 dots on the graph, lined up with the arrow pointing upwards. And those are the 4 quadrants that the x and y axis make. Pretty simple. This would be a scenario, these plots, where a 16-year-old lands his first job at a new restaurant in town. Part of the teenager's job duties require him to stand outside with flyers for the business. The teen is excited because he's offered $6 to stand outside handing out flyers, which you'll see the highlighted in yellow, the equation. That's what I'm talking about. So he'll hand out the flyers for $6, plus he gets $2 for each flyer that is redeemed by a new customer that comes back and purchases a meal. So that would fit this setting of the y equals 2x plus 6. The x represents the total number of customers ordering a meal, and y represents the amount of money the teenager makes. That is saying that $2 times the number of flyers returned plus $6. A list of some of the pairs that satisfy the equation, y equals 2x plus 6, would be 0 and 6, and you can see that first dot lined up on the x and y axis. And then the next scenario would be 1 and 8, and 2 and 10, and so on. And the first in quadrant 1, those would just be different scenarios. Like for instance, the 0 and 6, if nobody returned any of the flyers, he'd make $6, and so on. The other topic was function notation. If you recall from the previous flyer example, for every possible number of flyers that can be redeemed at the business, there corresponds a specific amount of money that one will make. The number of flyers redeemed is the input, and the output is one's pay. To make clear that an equation defines a function, one uses function notation, or f of x. Never f times x. These were just some of the questions and answers. You can go back and look at it if you want to pause the video and read them. I guess there's one here. In order to find the x-intercept, place a 0 for y and solve the equation for x. And in order to find the y-intercept, place a 0 for the x and solve the equation for y. That's what we did in the third slide. And that's all I have. I hope you enjoyed my simple demonstration of linear and function and the flyer example. Function notation was touched on as well, and one can use this information to implement into the rest of the unit. Learning the Cartesian plane for the first time or a refresher can be a good experience. Thanks for taking the time to watch my portion. I know you easily learned about that topic today. I'm going to hand it over to Jarvis, and he'll continue the conversation with quadratic functions. Hope I said that right. Let's see.
Okay, building models making some extra cash. Graphic interpret quadratic functions by Jarvis Riggs. Okay, how does a go solve a quadratic equation? By completing the scare. Since this past week was Halloween, I figured that was a good one. My name is Jarvis Riggs. I'm going to explain how to interpret and graph quadratic functions. During my presentation, I will be explaining in detail how to work a quadratic function. I'll also be explaining how to graph it. A parabola is the shape a quadratic function makes on the graph. The vertex is the uppermost or lowermost point on the parabola. The x-intercepts are the points on the x-axis where the parabola intercepts it, and the line of symmetry is the vertical line that dissects the parabola right down the middle. Okay, the basic quadratic function equation is f of x equals a times x squared plus bx and plus c. When graphed, it makes a parabola. Parabolas can be various shapes, and the function of the coefficient a shows how narrow or wide the parabola is. So, yeah. And the function of coefficient x squared shows whether the parabola will open to the top or will it open to the bottom. Okay, and the vertex of the parabola is the maximum or the minimum point depending on the shapes. And the axis of symmetry is the vertical line that divides the parabola. And it is also the line of x coordinates of the vertex. And that's a formula for the axis of symmetry, which is x equals negative b over 2 times a. That will give you the axis of symmetry. Okay, and to show an example of how the quadratic function is graphed, I'll use an equation of y equals 5x squared minus 20x plus 15. And first, you must isolate the x by dividing everything by 5. So you divide 5x squared divided by 5, 20x divided by 5, and 15 divided by 5. And that will give you y equals x squared minus 4x plus 3 if you divide the whole equation by 5. Okay, and then from there you can find the x-intercepts by plugging in 0 for y and then solving it. That will give you 2 x values, which is what it should be, as there are 2 times the parabola should intercept the x-axis. And ours are x equals 1 and x equals 3. And then you create coordinates out of these, and you have coordinates of 0, 1, and 0, 3 for the x-intercepts, as you can see right there. Okay, so next is finding the axis of symmetry. And to find the line of symmetry, you find the midpoint between both of the x-intercepts. In this case, it is 2. That will tell you that the x-coordinates is of the vertex. And after that, then you have to plug the 2 in for x and solve to get the y coordinate. And this gives us, if you plug 2 into the equation right here, this is gonna give us y of negative 5. So our vertex coordinates are the x is 2 and the y coordinates is minus 5, of negative 5, and that can be plotted on the graph. As you can see, I got a little picture right there. That's the axis of symmetry down at the bottom. Okay, then you go ahead and create the parabola based on those points as shown. And this one opens up to the top because it has a positive x squared value. So it's gonna open up. Okay, and then in real life, parabolas are everywhere. They can be used to show optimal profit on a particular product or an arch of a doorway in architecture or even various objects when thrown. And this is a graph of a ball being thrown as it goes up in the air with a particular amount of force. It can only go so high before gravity begins to pull it back to the ground. And the visible shape that this makes in the air is an example of parabola and a real life example of a quadratic function. Okay, in conclusion, quadratic functions all follow the same formula and can be easily interpreted in graphics. They create parabolas that can meet of various sizes and shapes. They can also go various directions. Okay, knowing the vocabulary surrounding quadratic functions can make your interpretation much easier. You must know how to get around a graph. You must have get around a graph, no coordinates, and the vertex. One way quadratic functions can relate to making extra money is to help figure out how much a particular item can cost, keeping in mind production costs, to be able to make the most profit. So quadratic functions also show the shape of objects when they are projected in the air and then are sent back to the earth by the force of gravity. All of these things show an arch in one way or another. That arch or parabola has a minimum point or a maximum point, which gives meanings to the whole concept. And that's it for my presentation. So next, let's hear what the next group has to say about the slippery slope.